So I'm Joshua, I work at Kazania. I'm also an associate at In Reality, and Louise is with House of Test. I come from a development background, and Louise has a testing background, and together we are Captain Planet. No, I'm just kidding. So what we're going to take you through today is a workshop on having more effective conversations in your teams about expectations of your system. Okay. It is going to be a workshop. It is going to be interactive. So if at any point you have a question or suggestion, please feel free to stop and ask. I don't mind getting interrupted. And everybody should have 2 pieces of flip chart paper on the table and some markers. Please put up your hand if you don't have flip chart paper and markers. Alrighty. Who in the room is involved in software development in some capacity? Awesome. Okay. So I hope you'd allow me. I'm just going to cheat a little bit. I'm going to look at my slides on my phone. Just as a reminder, please don't begrudge me that. I wouldn't ordinarily do it. Alrighty. So please tell me if this has ever happened to you. So a developer starts working on a piece of software. He's got a spec from an analyst or from a product owner. He or she works on the code for a while. After a day or 2, he comes to the tester and he says, "Tester, I've finished working on this piece of code. Could you test it for me?" And 10 minutes later, the tester, well, I really feel like I'm doing stand-up comedy, holding the mic like this. 10 minutes later, the tester comes back to the developer and says, "No, it doesn't work correctly. It doesn't work according to the spec at all. You've got it totally wrong. What were you thinking?" And the developer says, "Hold on a second." And they pull up the spec or the story or the documentation and they read it, and the developer says, "Look, read it. It does what it's supposed to do. It does what the specification says." And the tester says, "No, it doesn't. You're reading the spec wrong. It's supposed to be doing something else." And then they're not sure how to resolve this, so they figure out, let's go chat to the analyst/product owner, right? Oh, cool. We've got slides. Thank you. So these are my contact details if you want to get hold of me. Those are Louise's contact details if you want to get hold of her. Max, right? Alrighty. So the confused tester and developer, they both walk over to the product owner or the analyst's table and they say, we have a problem. We read the spec and I interpreted it this way and the test interpreted it that way. Who's right? And the product owner says, "Not my problem." Well, I hope the product owner doesn't say that. Product owner says, "You're both wrong." Right? Anybody ever experienced that? Sure. There weren't so many hands going up in the beginning, I was getting worried. So the whole idea of this workshop is to give you some tools and some practices and exercises around trying to solve this problem. So a problem that I've noticed coming up again and again, both in my experience as a software developer and as a coach and trainer, is we don't have shared understanding of what's required from our software across a team or across the people who are creating that software, right? So within this group of people, there are different understandings of what we expect from the software, okay? And probably even worse than that problem of not having shared understanding is the fact that we always find it late, right? It takes a long time and a lot of money before we actually figure out that we all understood different things. Does this sound familiar? Okay. I'm glad that it sounds familiar, because then hopefully this workshop will be useful to you. I'm also sad that it sounds familiar, because that's not a nice situation. Alrighty, so, yes, please. So, it's a workshop, so you're going to do all the work. I'm just going to stand here. So, in your tables, right, and if there's too few of you or too many of you at a table, please feel free to self-organize and level out the numbers. Imagine you're a group of people writing some software, Okay, and you're busy figuring out what the software has to do, and you're writing software for an ATM system. Okay, and you're going to have 10 minutes to synthesize a specification, including acceptance criteria for this user story, and an account holder can check their balance at an ATM. Okay, remember, you're a group of people trying to figure out what does this user story mean, right? What do we expect from our software system that we're creating within the context of an account holder being able to check their balance? Okay. Please feel free to use your flip chart papers if you want to write anything down. You can use any structure or whatever format you want. You'll have to figure it out yourselves. So you can appoint somebody within your group as a product owner if you like.
We're a remote team, access to nowhere.
So try to put yourselves in the shoes of, well, if you would do this at work, how would you go about figuring out what this user story meant? Okay, and you're going to have 10 minutes to go through that. Any other questions before we start? Let's have a quick debrief from that exercise. How was that for you? Any table want to share their experience of that exercise? How it went? Anyone? Lorraine?
So we started off confused about scope. We didn't know if we had to have the authenticating the card and the PIN number at the ATM. Then we weren't sure about, could the account be closed? And so scope was our first concern. Then we decided that it was prerequisites that they already signed in at the ATM.
Cool.
And that all we have to do is display the balance, and then those small details like in what language is a print displayed. That's where we were.
Alrighty. Any other group want to share their experience? Now I know who I can pick on. Any group come up with the acceptance criteria? Cool. Okay. Next question on the debrief. I would like everybody to show how confident they are that everybody in their group understood what was expected of the software we're creating. And the way I want you to vote is using a fist. So if you hold up 0 fingers, it means there is no chance that you have shared understanding across the team, right? And if you hold up 5 fingers, it means there's no doubt in my mind that everybody around this table knows exactly what we're trying to achieve. Okay? Everybody all right? Clear on that? Yep? That you reach in your discussion, right? So imagine again you're at work, you've been given this task, right? And yes, I've thrown you into the deep end without answering any questions, giving you a product owner. But imagine you're at work and you're given this piece of code or this feature to work on, and you're having a conversation, and now you say, okay, everybody, we're going to go and create the software. Okay. So on the count of 3, so everybody raise up a fist. On the count of 3, please remember from 0 to 5 fingers, 0 being no confidence, 5 being absolutely confident. And this is about shared understanding. So everybody around the table knows exactly what we're trying to achieve. 1, 2, 3, votes. Okay, so I see a couple of 4s, I see some 2s, I see some 0s. See a lot of 0s, I see a 1. Cool. Okay, so I didn't give you much time, and again, there wasn't a product owner, so it's okay if you don't feel confident. Out of interest, did anybody follow any particular structure for having this conversation? I see some nods, I see some nervous shakes. Okay. Faye?
We walked through Gherkin. I don't think we really finished that, but just time constraint, or tried to answer questions that way.
Alrighty. Okay. How similar was this to your experiences as in professional life? Not similar at all, very similar. Very similar. Okay. Should we be worried? No, I'm just kidding. Alrighty, so I'm going to give you a little bit of theory now. We're going to spend about 10 minutes on the theory, and then we're going to do another exercise after we've gone through the theory. Okay, so I'm going to show you a model called the States, Interactions, and Outcomes model, which is something that Louise and I have discussed over the last couple of months. And it's a way for teams to collaboratively explore, discuss, document, and specify what they expect from system behavior, with the goal being shared understanding. Okay. And quick feedback about shared understanding. So if we don't have shared understanding, we want to know that quickly as possible. Okay, so fundamentally, we interact with systems for an outcome, right? So somebody mentioned it's difficult to talk about checking a balance if we don't know why an account holder wants to check a balance, right? And in the connects and formula, the as a, so that, as a, I want to, so that, we try and bring that reason to be quite in your face, right? But fundamentally, we want an outcome, okay? And we're going to interact with something to get an outcome. Okay? There's something that exists, and we're going to interact with it to get that outcome. Okay. And the thing that we interact with is called the system. Okay, so we're going to interact with the system to get some outcome, and the outcome is really what that user wants, right? They don't really care about much else. They just want to know that their ATM balance is right. Okay. Go back. But here's the question, and this is one thing that I've seen a lot of teams struggle with. Okay. Is this picture complete? Obviously not. So what's missing from this picture? State, right? So we often forget that the outcome of an interaction is not due only to the interaction itself, right? The state that the system is in when we interact with it can change that outcome, right? So the outcome's a function of both the interaction and the state of the system when we interact with it. Does that make sense? Okay, I see a shaking head. So the way I like to explain this is, let's say there's a bear, right? And my interaction with this bear is I'm going to poke it. I'm going to run up to it and poke it. Simon, can I poke you to demonstrate? Right? Is the outcome of that interaction based purely on how I interact with the bear? Right? The outcome is different whether the bear is asleep or if the bear is awake. Okay, so the state of the system when I interact with it determines the output, the outcome, beg your pardon. Does that make more sense? Cool. Any other questions around this? I will make the slides available somehow. Alrighty, so we have a system that we interact with to get some outcome, and that outcome is based on the interaction and the state of the system when we interact with it. So in our particular example, what's the system? ATM. Okay. What about any connections to anywhere else? Is that part of the system? Anybody discuss that in the initial exercise 1? Okay. Just assume it's always up, right? So no matter what I do, I'll always get a result. What about the electricity supply to the ATM? Cool, 5 points to this team. Okay. So that's the system. So the first step that's really important when we're talking about a requirement is what are we talking about? What is the system? What are the bounds? What's included? What's excluded? Right? Again, remember we're trying to achieve shared understanding. We're trying to make sure that there's no differences in understanding among different people in this team. Okay. And if we can't even agree, or if you've got different ideas of what we're describing, it's going to make life a little bit difficult, I think. Okay. Anybody experience this problem where we're talking about the behavior of the system and I'm thinking and you're thinking? Okay, so if we can't define very specifically what our system is, we're already on shaky ground. Okay, so the first thing we want to do is be very deliberate about this is what we're talking about, this is the system we're exploring.
Can I just ask, in terms of defining the system, looking at the whole Agile process and iterative development and all that, what exactly is that system in terms of what I'm defining for my time box now, for example, for a PI, or is it my final goal, which could be 3-4 years down the line?
Okay, I'm a consultant, so I'm going to give the consultant's answer. It depends. So at something, I would imagine something like sprint planning or backlog grooming, we might be talking about this next piece of work. But please keep your question. Hopefully at the end we'll have time and we'll be able to chat about it further. Otherwise, you can catch me by the coffee table. Alrighty, so if we can't define this, we're in trouble. Okay, what's the next thing we should probably start doing? Well, now we know what our system is, let's start talking about how we interact with it.
Sorry.
Do you know how to use a Mac?
No, not with flipping PowerPoint. Sorry.
That's okay. And one more. So, when we're talking about checking a balance, what are the inputs? How do we know what the inputs are? Okay. Generalize. So we're not talking about ATMs anymore, we're talking about GPS systems. What is an input? How do we know when something's an input? Right. When the person interacting with the system supplies something to the system, that's an input, right? So when we talk about checking our balance, what are the inputs? What is the user giving to the ATM? A card and the PIN. Anything else? Account type. Maybe that's, we can assume it's linked to the card. So we're going to start with simple. There's a really simple ATM. We want to get to market very quickly as possible. So it's bare bones. Okay. So account number and PIN. Sounds reasonable? Well, hey, account number and PIN. Okay, who guessed those things? 5 points to you. Okay, so now we know what the system is, and we know what our inputs are, and the interaction, we know we're talking about checking a balance. That's what the user's doing. Now, what are the states of the system? Please proceed. So we're starting to fill out this picture. You can go one more as well. What states can the ATM be in? Sorry, one at a time. So I heard idle, I heard online, offline, broken. But my software never breaks, so we'll just ignore break. I don't know about your software, Mish. So online, offline, any other states? Are there any particular states that are pertinent to checking a balance? Cool. So we could be online but disconnected.
Whenever I'm trying to do anything, somebody seems to climb in the back and start loading money.
And I always get very scared with those assault rifles that they carry. So what about the actual amount of money that I have in my account? Right? So let's assume, let's not go down that path, we'll go down later. Okay, so to keep it simple, we're just going to talk about whether the ATM is available or not, so if it's offline or online, and what my actual account balance is. Okay, so next slide, please. So we have our system, we know what our inputs are, and we know our potential states. But the next piece we need to answer is, well, what is the outcome we're seeking? So the balance, anything else? Do we want to see it on the screen or print it? In my opinion, that's an input, because I'm typically supplying it as part of the interaction. But an outcome might be a printed balance or a displayed on the screen. What about error conditions? Maybe it's disconnected, etc., etc., etc. Okay. So I'm going to call the outcome reflected balance. So as an account holder, I want to check my balance so that I can see my reflected balance. Okay. I'm not personally a big fan of that format, but it's useful. Okay, so now we've completed this picture. We've got this wonderful picture of this is our system, this is how we interact with it, these are the things we're supplying as part of the interaction, these are the potential states that the system can be in, and this is what we're expecting to get back from the system, from this interaction, as a result of this interaction. Making sense so far? Any questions? Cool. Now, we said that we have the ATM there's this idea of availability and there's this idea of balance. So what are the potential values for this thing called availability? Right, we already spoke about online and offline and broken, which I'm going to ignore for the time being because it's not on the slide. Okay. And what potential values could there be for account balance? Negative, positive, 0, not a number. Yeah. My account balance is probably close to not a number. Sorry, Gustav? What precision are we looking at? So to keep things simple, we're just going to look at when the ATM is online, when the ATM is offline, when my actual balance is 0, and a typical case where my balance is 100. Unfortunately, that is quite a typical case for, no, I'm just kidding. And the next thing we want to talk about is the input. What are the different values, potential values for the inputs? So remember we had account number and PIN. So potential values for account number. An account number can be valid or invalid. Okay, makes sense? And a PIN can be correct or incorrect. Okay. Well, look at that. Okay, you guys are like prescient. You know exactly what's coming up on the slides. Okay. So now we know these are all the states that the system can be in. These are all the inputs we're supplying. And these are the potential possible values for the state, right? So the system can be in certain types of state, which is a combination of all those values, the Cartesian product. And now we can start doing some interesting things, right? So we said that the outcome of interaction is a function of the interaction itself and the state of the system, right? So if we can specify the outcome for a particular state and interaction, what we're starting to do is we were saying, well, my ATM's in this state and I give it this input, what am I expecting? Starts to sound like we're talking about what we're expecting from the system, right? How we're expecting the system to behave. Does that make sense? Okay. And the kind of fundamental theory of this model is if we can specify the expected outcome for every unique combination of states and inputs, right, then we have completely specified all the expected behavior of our system. Okay. If we have found all our states and all our inputs and all the potential values for each of them, we can start saying, in all ways that any user can interact with the system, this is what we expect the output to be, the outcome. That we've thought of. That we've thought of.
So that's actually my question is, in a real world system, how realistic is it to think that you've seen everything? Louise is shaking her head.
So that's why Louise is a co-presenter.
No, and I think the important thing to remember is that the important thing to remember is that what we're trying to do here is talk about looking for correctness and kind of understanding together what that actually means. And there's a whole bunch of other testing that still needs to happen.
So notice I haven't said the word testing yet. Okay. All we're doing so far is exploring how do we expect this ATM to work. And we're exploring it together. Okay. But I want to come back to your question a little bit later because, in my opinion, the technique that we're going to show you now goes a long way to helping answer those kinds of questions. Okay, next slide, please. Okay. I feel like we got one of those old-time slide machines that you click the button and a carousel. And okay, so remember I said we've got this idea of if we can specify the expected outcome for every combination of input and interaction and state, we can specify expected behavior in totality. So let me ask you this. If the ATM is offline, okay, does anything else matter? Nothing else matters. Okay. A song. Well, there's a mic if anybody wants to come and sing it.
What about error, Tim? Don't you want to display that?
Ah, error. Cool. So next slide, please. See, I knew that was going to come up. So if the ATM is offline, doesn't matter what any other state is or what the input is, right? We're going to get an error, ATM's offline. Okay? And in the real world, that actually happens before we even start interacting with the ATM because it says offline, so we walk away. But if you imagine this almost like an API transaction, you could send a message and the reply back is, sorry, the ATM is offline. Okay, make sense? So, what happens if the ATM is online, but our account number is invalid? Does it matter what our actual balance is? Doesn't matter what the PIN is. What's our expected outcome? Error. Oh, you guys are good. Right? And you'll notice there's this column on the end called name, which is, we can just start calling these particular combinations. We can give them a nice name that we can all refer to that's nice in English, easy to talk about. Okay. Let's say the ATM's online. the account number is valid, but the pin's incorrect. Does it matter what our actual balance is? Doesn't matter. Our expected outcome is incorrect pin. Okay. Everybody on board at the moment? Cool. Everybody see where this is going? Cool. What happens if the ATM's online, the account number is correct, the PIN number is correct? What do I still need to specify? What else affects the outcome of that interaction? Anybody see the red question mark there? Right, so if the ATM is online and my account number is valid and my PIN number is correct, the only thing else that affects the outcome of the interaction is what my actual balance is, right? This is happy path. Yay, happy path. Right, developers test, yeah, it's working, yay, happy path. Sorry, just me, not other developers. So now we can say that when the ATM is online, the account number is valid, the PIN number is correct, and I have nothing in my account, then I get a good answer, I don't get an error condition, and we can call that the zero balance scenario, zero balance case, zero balance condition. And for completeness, we're just going to talk about a typical balance scenario. Carl? That's an interesting question. And this particular model, this approach ignores that particular scenario. But it is an absolutely valid concern. I would imagine the expected outcome there, some kind of error condition, connection lost, load shedding, something like that. So does this, yeah?
No, but I think that's kind of the point we're also making, is that this is going to help you to explore and understand together as a team what your acceptance criteria are, what you're expecting something to do, and then looking for problems is another aspect of testing that we're not really talking about here.
And with reference to Neil's question about, so we have this thing, all these scenarios that we've thought about, right? And for me, the value in this is it makes these things super explicit and super obvious, and it starts to show us the relationship between these things and the outcomes. So how do these things affect the outcomes, which starts prompting questions, but what about this, but what about that? Okay. Agile boys and agile girls.
We usually have some analysis, some development, and some testing that's going to happen. But really, this is actually fixing. And what we're really trying to do is optimize the actual fixing portion such that it becomes really small, because the quality of what we've done here, we've got lots and lots of little feedback loops all through there, so that what we're ending up with going into a phase where we're now really exploring is of a much higher quality. So the effort that we need to then spend on fixing stuff at this point is a lot less.
So just based on that picture, one of the ideas behind this technique is we can start trying to get some feedback around shared understanding before we even start writing software. Okay, so if you think of testing, and please correct me if I'm wrong, if you think of testing as finding and mitigating threats to product value and quality, right? Well, this allows us to start testing before we've even started writing software. Because we're starting to uncover and mitigate threats to the quality of the product. Okay. Next slide, please. So, anybody heard of given, when, then? Okay. So something interesting when we talk about the state, that's given. So given the world is in some state, when I interact with the system in this way, then I expect this outcome. Okay, so what we've been doing is called behavior-driven development, okay? Which is over a decade old, which is interesting. So if you use given, when, then, this table format is a way of, so this technique is called specification with examples, right? So Michael Bolton taught me that. Not specification by example, it's specification with example, okay? And we're specifying expected behavior with concrete examples. We're not talking about business rules, we're talking about, given this concrete scenario, right? Given the system is in this concrete state, when I interacted with it in this way, this is the concrete outcome I expect. Okay. Next slide, please. So, just to reiterate on the steps that we've gone through, the first thing we did is define the system and the system boundaries. What are we talking about when we're talking about this system? What's in, what's out, right? So we're not talking about how we calculate an actual balance. We don't care. We're just getting that from somewhere. That's the state of something else, right? And, right. Then we talk about what are the inputs to the system, right? In this particular case, account number and PIN. Then we spoke about the different states, availability and actual balance. Then we spoke about, well, what does the outcome consist of? What does the outcome look like? In this particular case, it was reflected balance and maybe an error condition or an error condition. Then we looked at the possible values for the different states, for the different states, possible values for the different inputs, and we went through each unique combination of state, concrete state, and concrete input, and we spoke about what is the expected outcome. Just a very quick note. How do you tell the difference between an input and a state? Right, so if it's not provided by the user as part of the interaction, it's the state of the system, right? So the user doesn't provide the actual balance when they're checking their balance, right? But it's something, it's a variable that affects the outcome, state, okay? And that's the litmus test. Did I provide it as part of the interaction? Yes, input, no, state. Simple as that. Okay. So now we're going to do another group exercise, okay? And what I want you to do in your tables, in your table groups, is go through the same exercise, but now you've got a new scenario. So we're not talking about checking a balance anymore. We're talking about withdrawing cash from an ATM. So an account holder can withdraw cash from an ATM. So you'll have about 15 minutes for this. Right, we'll go until about 22. And I'd like you to use this structure that we've just spoken about and these things, system, interaction, outcome, etc., to structure and have your conversation around this functionality, okay? I did have handouts for you, which is very well prepared for me, but they were in my laptop bag that's gone AWOL, so I'm going to put up Louise is going to put up the handout very kindly for us. Yay, Cloud. Yay, Cloud. Just so that you have those steps. So you can put it on the slideshow. It's just the previous slide. Because it's a Mac. Yeah. Try Shift F5. Woohoo! Okay, so again, the scenario is as a user, I want to withdraw cash from an ATM. The steps again: define the system, what's in, what's out, define the inputs, define the states. What does the outcome look like? For each type of state, what are the potential values? For each type of input, what are the potential values? And then building up a table, unique combinations of state and input, what is the outcome you expect? Okay. And your marks, get set, go.
Sometimes if there's no hundred, or you ask for 2,000, it says I've only got 1,000.
Alrighty. So unfortunately, we don't have too much time left. I'm going to have to switch the microphone. How's that? Unfortunately, we don't have too much time left, so I'm going to continue. What did you notice, experience, observe, feel during the second exercise? Less uncertainty.
More structure.
Mo-
There was a lot of uncertainty and confusion until we started writing examples. And then everyone could say, oh, okay, now we know what you're talking about.
Okay. So when you got concrete, it made things a lot clearer. Correct? Okay, so it's easier to not miss scenarios. Okay.
The non-functional requirements you mentioned still stand, like the whole needs electricity, blah blah. So you just need to focus on the functionality itself.
Cool.
We were quite tempted to talk business rules instead of using concrete examples.
Did you? Well done. Glad you resisted the temptation.
Even though we started writing, okay, if I had not had the courage or I'd been like, oh, I'm going to sound stupid, ask a question, I actually would not have understood. Again, because the way my brain works, the way I would have written it out, is very different to the way the rest of the team works, which is fine. But I didn't understand it until I asked. You could have handed me that, and I wouldn't have known how to test it. So it's still, I think, important that even though I think the emphasis lies in the discussion and not necessarily the outcome.
Right. And for me, that's a really important point, right? Because a product owner could create that table by his or herself and give it to the rest of the team. Well, it's just a different format for giving specs, right? But the real power in this technique, and again, this is a structure for having the conversation. What's more important is the conversation and that it's collaborative and that everybody's involved and everybody gets the opportunity to ask their questions and discuss it and say, I don't understand this, or what about that, or are you thinking this? Okay. So as useful as the format is, and the format is useful, again, the primary point of this whole thing is the activity, the conversation, right? So we're collaboratively, all of us, exploring, well, what are we expecting from the system? Okay, we have the opportunity to ask questions. It's explicit that different degrees of freedom that we're talking about, you know, what are the states, what are the inputs, and how do they affect the outcomes? Okay. How did the second exercise compare to the first exercise? Better? Okay, more engagement. Cool. Any other observations? Okay. Much quicker to common understanding. I've run this exercise in teams. I did some training at a bank last year. And the one group I had, there were 6 people, 3 of whom worked on system A, 3 of whom worked on system B. We did this exercise retrospectively on one of their systems, right? And the people who worked on system B had never worked in system A, had no idea what it did, what it was for. Within about an hour, right, the people who'd worked in system B had a really good understanding of what system A did, not necessarily how it did it, but what it did, and how what the different states were, what the interactions were, and had a really good high-level understanding of what the intent of that system was. I want to do another confidence vote. So the rules are the same. Put your fist up, and again, 5 is, I have no doubt that everybody around this table knows exactly what we're trying to achieve. No fingers is, I have no doubt that nobody around this table knows what we're trying to achieve. 1, 2, 3, votes. Okay, so look, I see 4s and 5s. I don't see any 3s. Alrighty. How are we doing for time? Oh, we've still got a bit of time. So what I want to show you now, again, I want to stress that the important part of this is not the artifact, not the document you've created, but the conversation. However, what's often really useful and a heuristic that I like is, people say, oh, in Agile we don't write documentation, we don't plan. So we all know that that's not true. But what's a very effective technique that I kind of use is the timing of these things is very important, right? So we can document something and then have a conversation about it. Or we can have a conversation about it, gain shared understanding, and then document our shared understanding. And that second scenario for me is much more important. So again, the primary thing is the activity, the conversation. There is still value, however, in the document, in the artifact that you've produced. What I'm going to show you now is some C# code that I would typically write once going through an exercise like this for something like the check balance. So the code I'm going to show you is C#. It does compile. It's not going to be too complicated, so if you've never seen source code, don't worry. You won't run out the room tearing your hair out and screaming. Okay? So on that note, we spoke about one of the first examples. Given the ATM is offline, when I check my balance, then I get an ATM is offline error. Okay? So this is C#. This compiles, it's legal. It's using a library called NUnit to just run the test, but it reads like English. Note, I'm not using Cucumber or any of those tools. This is just raw, plain C#. With another tool called LightBDD, which is very, very simple. But the idea is we can take this table or this grid that we've drawn up together. What would be quite useful is we tear it off the flip chart, we take it back to our workspace, we paste it up on the wall. We've given things nice names, so see here's the name ATM offline, here's the name incorrect PIN, and we can talk about the ATM offline case or the incorrect PIN case, okay? But what I want you to notice specifically in this code is that it reads very much like English, okay? And Louise has told me that my code is really beautiful, so it's something that I'm very proud of.
Especially your test code.
Especially my test code, my checking code, This is the kind of scenarios when there is a balance. A little bit more complicated. So again, given the ATM is connected and given my account balance is 0, when I check my balance, then the reflected balance is 0. Given the ATM is online and my real balance is 100, when I check my account balance, then the reflected balance is 100. Okay. And again, this is valid C#, compiles, runs, executes. And I wouldn't even call this a test. In my opinion, this is a spec. Right, I'm specifying what I expect from our system, which is exactly what the activity is about, right? The exercise that you've gone through is about figuring out what do we expect of the system, how do we expect it to work. Okay. Sure.
So for me, being a tester, there's a couple of awesome things that happen when you do this with the developers on your team. The one is that this is a lot more descriptive to me than comments sometimes, code comments. Everybody now has a shared understanding in the team of what do we expect this thing to do, and I know that there's a certain level of things that are already covered by unit tests. So those are not things now that I need to stress about or lose sleep over. I'm going to now look for the real meaty, serious, deep, dark stuff. I know that these things we've spoken about, we've got unit test coverage, it's going to run every time the build runs. We're like in a great place. So that's really powerful. I've also seen that sometimes teams I've worked with, the devs can struggle sometimes to figure out, well, what do I unit test? Like, what do you want me to unit test in this scenario? And just by using this kind of example and actually talking through specific examples using states and interactions and outcomes, we get to this common understanding, and he has a much clearer idea of, okay, what do I want to actually unit test, which is awesome. So thanks, Josh.
So just to reiterate, this doesn't replace testing, right? So there was one thing I've got to mention earlier. These specs in the programming language are written before you write your production code, right? So we know what we're trying to achieve. We know what expected behavior is, and we can automatically verify it. Right now, we can go off and design the system however we want to. We can always ensure that it's working as we expect it to. Just a little bit of a note around the testing. So this works really well as a target. So the kind of thinking that I like to use is just because the system works the way we expect it to, doesn't mean it doesn't work in ways in which we don't expect it to. Right? So this doesn't obviate the need for testing, right? It gives everybody a nice target to work through, but we still need to check, for example, does it misbehave in unexpected ways? Okay, and that's something we can't do in this way because this is all about expectations. Okay. We've got a bit of time. Does anybody have any questions? And you would also have it from on a recursive basis. So Kent Beck mentioned this morning about recursion. And just in case you don't know, in order to understand recursion, you have to first understand recursion. Okay, so that's a bad programmer dad joke. I'm a programmer dad, so I have to make those kind of jokes, right? But within a system, you might have subsystems. So for example, we might start talking about, well, how do we know if an account number is valid? Right? That piece of code could be its own system with its own state and its own interactions and its own outcomes. Right? And its outcomes would feed into the larger system. And again, with this ATM story, there is a larger system because it needs to include everything outside that circle. But typically, we chunk things up in order to understand them and specify them as we go along. Something that's just popped into my head, which I forgot to mention earlier, is one of the reasons why I like this technique as well is once we've looked at all the interactions and states, it's very easy to say, for phase one, we're going to ignore these inputs and these states. Right? So we could have spoken about an account being open or closed or suspended. Right? Do we want to specify that now, or do we want to release code earlier? Okay, so it makes it easier to start drawing that line around, if we want to develop and release iteratively, how do we figure out what's in and what's out? Or develop a kind of roadmap or release plan about successive iterations. So there's, yeah.
Ubiquitous language.
Oh yes, the other really important thing is the ubiquitous language. So you'll notice that when we were talking about the system, the states, the interactions, and the outcomes, I didn't use any technical language. Right? We just spoke about very high level English, non-technical words that everybody in the team should understand and should make sense to everybody, right? So we did at times, for example, talk about printing a balance or showing it on a screen, or we can just talk about a reflected balance. I didn't talk about how we input the PIN or how we input the account number. So there's no implementation. It's purely from a functional point of view, from a user using the system, how is the user going to interact with the system, and what do they expect from that interaction? Thanks for mentioning that. You had a question?
Yeah, I wanted to ask, what do you think about having the PO be participating in this? Because sometimes I've found that the PO doesn't know what he wants until he says, no, this is not what I want.
So I believe that you need working software to crystallize what you want. Absolutely. I see this as a potential shortcut to that. Right, so the product owner, for me, is critical in being involved in this conversation. And it's not software, but it's starting to put tangible, concrete things together that we don't have to try and interpret, for example, business rules in our mind, right? So for me, it's a way almost to start crystallizing that thought of what the commissioner of the system wants before we even start writing software. So it's much quicker, much cheaper, much less wasteful.
I've worked with teams where the product owner eventually will get to the point where they do start writing these, or that's their starting point, and then you come together and refine it. So you can get there. It takes a while.
So takes a while. Any other questions? I just want to apologize again for the technical difficulties, but thank you very much. I appreciate your time and hope you found it valuable. Enjoy the rest of the conference.